All right, so we're going to prove that for every natural number n, 1 squared plus 3 squared plus 5 squared plus dot 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 plus 2n minus 1 squared is equal to this formula here. We're going to do this, so prove by the principle of mathematical induction. So our base step, we're going to consider a p of 1. So that's 1 squared is equal to 1, of course. And 1 times 2 times 1 minus 1 times 2 times 1 plus 1 over 3. So that's 1 times 3 over 3, which is, of course, 1. So that works. Let's consider a p of 2. So the sum of the first two terms in this series is equal to this formula. So that's 1 squared plus 3 squared. So that's going to be 1 plus 9, which is equal to 10. Now the formula is 2 times 2 times 2 minus 1 times 2 times 2 plus 1 over 3. So that's going to be 2 times 3 times 5 over 3. The 3 over 3 is 1, so you are left with 10. So that works out. So at least it looks like it works, right? So let's do the induction step. Suppose P of k is true. Thus, we have 1 squared plus 3 squared plus dot 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 plus it was 2k minus 1 squared, right? 2k minus 1 squared, yep, is equal to k times 2k minus 1 times 2k plus 1 over 3. So we're going to assume that's true for some k, right? Okay, so consider the sum of the first k plus 1 terms, right? So 1 squared plus 3 squared plus dot 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 plus 2k minus 1 squared plus 2 times k plus 1 minus 1 squared. All right, from our inductive step, right, from our induction step, we know this sum, right, is equal to this formula. So we know this is equal to k times 2k minus 1 times 2k plus 1 over 3, and then plus what we have left over. That's going to be, I'll find a common denominator of 3, so 3 times, and this is going to be 2k, it's going to be plus 2 minus 1, so plus 1 squared over 3. Now I can see I have a factor of k plus 1 in both of these. So I'm going to factor out that, or 2k plus 1, right? So I'm going to factor out that 2k plus 1. And I'm going to be left with k times 2k minus 1. Plus 3 times 2k plus 1. All over 3. Because I just factored out the 2k plus 1 factor from both of these, right? So that'd leave me with k times 2k minus 1 plus 3 times 2k plus 1. Okay, so let's see. So we have 2k plus 1. I guess let's look at what this gives us. This will give us 2k squared minus k plus 6k plus 3 over 3. Now let's see. So 2k plus 1, 2k squared plus 5k plus 3 over 3. So what am I looking for? So I need that to be a k plus 1. So I need a factor of k plus 1. So let's see, 2k plus 1, k plus 1, and then this would have to be 2k plus 3, right? Over 3. K times 2k is 2k squared. K times 3 is 3k. 1 times 2k is 5k. And then 1 times, yep, it works out. So this is equal to, so let's see, it would be k plus 1. And then I need that 2k, so 2 times k plus 1 minus 1. But that's the same thing as 2k plus 1 because this would be 2k plus 2 minus 1 is 2k plus 1. And then I also need the 2 times k plus 1 plus 1, which is 2k plus 3, right? Yep, so I get the formula I need. So I've shown that the sum of the first k plus 1 terms, right, is equal to this formula if you plug in k plus 1 into the formula. Therefore, by PMI, for every n contained in the natural numbers, I know 1 squared plus 3 squared plus 5 squared plus dot 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 plus 2n minus 1 squared is equal to n times 2n minus 1 times 2n plus 1 over